Okay, so today I'm gonna discuss with you our tool, Climameter, that is a tool to perform rapid attribution to climate change. And Climameter is based on Copernicus data, so it's a pleasure for me to present it in this situation. So I will first start and let's see if I can move forward the presentation for the moment. Yes, here it is. Let's start to say what is Climameter. Climameter is many things, but is first of all a consortium of international scientists that are all over the world. At that time, happy to coordinate from the CNRS in Paris. And the goal of our consortium is to perform attribution to climate change of extreme events that have happened in a very timely manner. In fact, what we aim to is to have our reports ready in 24 to 48 hours after the event. And in fact, as you can see, if you navigate in the website and you will have a QR code to reach the website at the end of the presentation, you will see that our last event that we have covered is the fire in Canada that is ongoing. So sometimes we also have ongoing events. And for the moment, we have over 70 events. And the idea of having these attribution reports ready in short time is that we can communicate to the international press. For the moment, we have hit over 2,000 international press articles. Sometimes it's difficult to estimate the right impact for our reports because what happened is that some press agencies such as Reuters, AFP, or ANSA, they take our reports and then the newspaper publish the results in cascade, and so we have many times the same kind of articles that appear in different journals. So for this presentation, I start from the results. You can see here a map of the events that we have covered so far. We have a global coverage, although we would like to strengthen our coverage in the global south. And you can see different colors that corresponds to the different kind of events that we cover in Climameter. The light blue is related to windstorm. The blue is related to floods. Then we have violet that is related to cold waves. We have yellow for heat waves, and we have red, although you cannot see them here, for fires. And the output that Climameter provide is how we can attribute an event to climate change. So you can see that for about 15 events, we have that the events have been strengthened by climate change or likely strengthened for climate change for 30 events. And then we have an interplay of natural climate variability and climate change for about 30 events, and just 3 of the events that we have analyzed out of these 70s are not linkable directly to anthropogenic greenhouse gases emissions. So we see that in most of the events that we have analyzed, we can really detect an influence of anthropogenic climate change on the events. And another output that Climameter provide is the rarity of the event. Most of the events are very exceptional, which means that we don't have other events that look like the ones that we want to attribute in our dataset. And this is also interesting because the rarity of the event allow us to put score of confidence on the kind of analysis that we provide. So given all these results, how do we perform our studies? First of all, I want to recall what is attribution. Attribution is linking an event that produced some impact on health, infrastructure, property, tourism, agriculture to the sources that can be greenhouse gases emissions or the natural climate variability. So these impacts are produced by climatic hazard. For example, if we have strong winds, we can have damages in the infrastructure. If we have heat, we can have impact on the health or on the tourism, and so on and so forth. So the idea is that this climatic hazard can be, of course, directly analyzed by looking at the time series of the hazard themselves. But in climate meter, what we do is that we link this hazard to their origin, that is the weather phenomena that is producing the hazard and then the impact. For example, a cyclone can produce at the same time wind and rain hazard. And therefore, by looking at the level of the weather phenomena, we can at the same time attribute to greenhouse gases emission or climate variability of an interplay of the two several hazards at the same time. So that's the goal of climate meter, and also why it is different from other attribution methodologies that instead are based on looking at directly at the hazard. Looking directly at the hazard, for example, if we consider rain, can be sometimes misleading because rain can be produced by very different phenomena in the weather. We can have rain because of thunderstorm, that is a very small scale phenomena, or we can have rain because of large scale synoptic meteorological structures such as tropical or extratropical cyclones. So going to this level allow us to really understand the physics that is leading to some change because of greenhouse gases emissions or natural climate variability of some hazard. So how do we do? As I was saying, we use Copernicus data from 1950 to present, and what we look at to being able to detect changes in our events is the large-scale pressure structure in a longitude-latitude box that fits our event. And the method is very simple because it's based on analogs of this pressure pattern that we have defined as a long latitude box containing the event. And therefore, what we do is that we assess difference present versus past analogs, having the hypothesis that the past is barely affected by climate change and the present is highly affected by climate change. By looking at the difference between pressure maps associated with the analogs, we can also look in cascade to the different hazards during these analogs. So, of course, pressure, but also temperature, precipitation, winds, or other impacts variable. And of course, just looking at statistical changes will not allow for attribution because we have to include or exclude the role of natural variability that we do by looking at the main modes of natural variability such as El Niño Southern Oscillation, ENSO, AMO that is Atlantic Multidecadal Oscillation, or PDO that is Pacific Decadal Oscillation. The best way to understand climate meter is through an example. So I will show you here very briefly the storm Eowyn. That is it's an explosive storm, an extratropical cyclone that hit the British Isles and France recently. And basically we had a drop of 50 hectopascal in 24 hours, a pressure minimum of 940 hectopascal, extreme winds above 130 kilometers per hour, and impacts, many impacts, especially on the property damages and the energy sector. So how does climate meter work? We do an analog search. So you can see here for the top left panel, the sea level pressure anomaly. That is what we look in terms of analog for the storm Eowyn that occurred the 24th of January 2025. So we select about 30 analogs in the past period, that for us is 1950-1986. We select the same number of analogs in the present period, that for us is 1987-2023 for this storm. And then you can see that the last column is the delta, that is present minus past. And this delta shows that storm similar to Eowyn have intensified in terms of having a deeper pressure minimum in the present compared to the past. And we also see that there is a positive pressure anomaly over the continental Europe, and therefore we have a stronger dipole of pressure. So let's see what this implies in terms of temperature. First, we can see the temperature during Eowyn, still this left plot. Again, we have the past and the present temperature during the analogs of pressure, and then we can see that the temperature is generally higher, up to 3 degrees warmer in the present compared to the past on the British Isles and North France, the Benelux and Germany, while we have a lower pressure because of the deeper pressure gradients here. And we can see that we also have higher precipitation in Scotland and in the English Channel, and we can have stronger winds. So that's basically the methodology. We can also detect whether the event is rare compared to the analogs. So here I show you two distributions. The blue distribution is in terms of a violin plot, the distance from the analogs, from their analogs for the past and the present, compared to the blue dots, that is the distance of the event, so storm Eowyn, compared to these analogs. As you can see, if the blue dots, like here, is inside the distribution, we can see that this event is not exceptional, so we have good analogs, and therefore we have high confidence on the kind of results that we have produced. We have robustness on the methodology that has been explored in the work that you see cited here. And similarly, having the dates of the analogs for the past and the present, we can look how the El Niño Southern Oscillation, the Atlantic Multidecadal Oscillation, and the Pacific Decadal Oscillation could have influenced the event. So you can see here that we have the shift between the distribution of the past, again in blue, and the present analogs during for the different indices, and in this case only the Atlantic Multidecadal Oscillation has a significant shift according to a Kramer-Formiset test, and therefore we cannot rule out that the changes that we see and that we have commented before can happen because of a different phase of the Atlantic Multidecadal Oscillation. So we summarize all these results in the kind of output that you can see in the Climameter website. So the role of the natural variability is basically expressed from the first meter here, that for every mode of variability that is significantly different with present with respect to the past, we go from strengthened to climate change to influenced by natural variability. And the assessment of the rarity is what you see in the second meter, where you can see that our event is not rare, but it's not even very exceptional. It's somewhere in between, given our analysis of the distance from the analogs. The plots are always presented in the same way. They contain again the results that I shown. So the first row this time is for the event themselves. We have pressure, temperature, precipitation, and wind during the event. And the second row is the changes that I have already commented with, showing deeper pressure, higher temperature, stronger precipitation, and wind speed increased. So we give all of this to the press. So with the summary that you can find for each of our events and contain 3 items. The title show that the event has been strengthened by climate change. Then we have an item that tell us how changes translate in terms of pressure, winds, and precipitation, the rarity of the events, and the attribution statement that in this case says that we mostly attribute the increased powerful storm of Eowyn to anthropogenic climate change. So the key features of climameter from this first example that I show you is that we are fast, we can link the events with the meteorological conditions, and we have a physical interpretability of the change that we have commented, because like in the case of Ewin, we have deeper pressure that entrains changes in terms of wind and precipitation. And of course, the other things that is our also working platform for the moment is that we want to include climate models for the future. I finish with some references and I thank you very much for your attention. You also find here a QR code that will drive you through the website, and of course you can write us to give us feedback, and I'm very happy to answer the questions that you may have about Climameter. Thank you very much.
Thank you, David, for your presentation. It was really interesting, and we have a few questions for you. So I'll just wait till it appears on the screen. The first one, so interesting presentation. I will be glad to provide inputs over West Africa. Is it possible to join your team?
Yes, of course. So if you basically write an email to the email that you've seen before, or the contact that you have on the website, our consortium is open to the colleagues. So if you want to join, we are very happy that you join. And we're also realizing a study on the last 30 events on Africa in the last 5 years with African scientists, because we've seen that we have this weakness that we struggle to cover events in this continent, and therefore we will be very happy if we strengthen the African team of colleagues and in general the global south with more colleagues coming from these areas.
Okay, good to know. Thanks a lot. So yeah, the presentation will be made available in a few hours, so you will be able to see the contacts and everything. Thanks a lot. The next question: could you study other events with Climameter?
So yes, we can study other events, and we have some peer-reviewed materials that extend our study. For example, to the dust storm that we had in Europe in 2024 and that we have continuously. And so with the analogs approach that I showed, we have analyzed the dust storms that occurred at Easter time in 2024 in Europe. And we are extending the methodology also to cover convective events, large-scale outbreak. So I have a paper in collaboration with Columbia on the tornadoes outbreak in the US that can start to be covered with this methodology. And I'm working now at covering hailstorm, like the hailstorm that we had in France in May 2025. And the methodology is versatile because once you have this link with large-scale conditions and hazard, you can apply the methodology to other class of events.
Okay, thanks a lot for the explanation. So we will go to the next question. Is there an area or areas where these hazards concentrate more?
Bad news. Thanks for this question, but I mean, we have currently hazards everywhere in the world. So, of course, there is a different vulnerability of different areas. For example, tropical areas are more vulnerable to floods, heat, but humid heat, and tropical cyclones. And instead, the mid latitudes are vulnerable to fires, to extreme heat, to floods, to extratropical cyclones, and to thunderstorm. And therefore, we have different hazard in different areas. But for the moment, we receive every week requests to cover hazard all over the world. So, and it's not expected to get better unless we reduce the CO2 emissions.
Yeah, exactly. Thanks a lot for the answer. So thank you. You mentioned using ocean pressure data from the 50s. Which are they based on?
These are definitely thanks for the question, Copernicus data. So we use ERA5 and we trust, all our methodology is based on the fact that we trust ERA5 reanalysis, and there are many studies that say that we can trust ERA5 reanalysis for these large scale fields such as pressure, temperature, precipitation, and wind. And the thing is, we also used in the past other dataset to compare, for example, NCEP reanalysis, but which are at a lower resolution. So the power of ERA5 is that we can really go to the 25-kilometer scale. That is the one that is relevant for large cities, for distinguish the topography, and this is really the advantage of using this kind of reanalysis.
Okay, thanks a lot. So the next question, how does spatial scale accuracy affect the reliability of climameter results? Does it provide better insights at a global or regional level?
Thank you for this question. So, climate meter, as you can see from the example, we have to cut a certain area that fits our meteorological structure to perform the analog search. So it performs better at the regional level. If we extend the domain and we take a domain that is too large, then we will fit more than one cyclone, more than one anticyclone, and in that case, the analog's quality will lower. So the best practice is to fit the structure that we want to attribute. It is the one that is producing the hazard, which means that there is a lot of expert judgment with this climameter. And the other problem is that if we take the area too small, then we don't have a cyclone and anticyclone. We have just few grid points, and in that case as well we can have problems. So there is an in-between that is the good structure that fits our synoptic conditions that is producing the hazard.
Okay, thanks for the explanation. I think it's clear now. The next question is a tricky question. How Climameter is better than any other climate tools for global data management of climate change?
So I would say that Climameter I will reinterpret the questions, and thanks for this question, as compared with other attribution framework that have the same goal. So in fact, there is the advantages of Climameter with respect to the other methodologies to have this physical interpretability of the changes, because we have at the same time all the hazards and we link them to the meteorological conditions that produce them. But it doesn't mean that other methodologies that are based at looking, for example, at changes in the hazard are not useful. For example, the World Weather Attribution, that is the other consortium producing attribution studies with the statistical methodology, it has also a very important component that is linked to the vulnerability and the exposure of the population to the disasters, and that part is not in Climameter, but it's really useful because it links immediately the changes to the populations that is affected by certain hazards. So there is collaboration between Climameter and all the other consortia that realize attribution studies, and this is very nice. In our community, our goal is also to provide timely information to the population, and this is the goal of the attribution community. And although we have different methodologies, we have this common goal, and we discuss a lot among each other on how to reach this.
Okay, thanks a lot. So we have still time for a few more questions. How do climate variability models from CNRS help in predicting future threats to endemic species in vulnerable regions? So I don't know if you know that, but
Okay, so this can be, for the moment, we are not doing this because attribution is present versus past. But of course, the same methodology of the analogs, we can produce a study on projections. We have to define warming levels. We have to define models. For example, yes, we have a IPSL model, that is a model the CNRS is participating, and project this in the future, right? But for the moment, we have not done it. We can foresee how to do it, but this is also part of the things that we are currently developing in my team here at CNRS, and not for these specific studies, but yeah, definitely you can use the analogs for also doing projection.
Okay, thanks a lot. Another question. Do you think we can study permafrost degradation with climate meter?
Again, the climate approach, it's more broadly the analogs approach. Yes, you can study other phenomena on longer time scale, but then you have to change data set. For example, for the permafrost, I guess you have to use longer reanalysis and also models that can take into account the dynamics of the permafrost. And then you have to come up with a good observable for which you have to compute the analogs. Of course, it cannot be sea level pressure. So you have to adapt the methodology, but definitely you can do it.
Okay, thanks a lot. Okay, so we have time for a few more questions, but I think we will stop after the three we have. Does climate meter allow for near real-time operational services of any event which local meteorological service defines as extreme weather event?
So, in some sense, we can cover globally the event that come up, provided that they are in the events that we can cover, that for the moment are heat waves, cold spells, floods, cyclones, and fires. So we are working at the extensions to other events, such as I was telling, the convective hazards, tornadoes, hailstorm, but these are experimental for the moment, and we have to wait that these studies are peer-reviewed and published so that we can make a new version of our protocols that take into account also the new hazard.
Okay, thanks. And so next question. So is climate meter a Python framework? And if yes, what is the input and what kind of output can it give?
Okay, so Climate for the moment runs in MATLAB and in Python. And for the output you have seen, the output is exactly the figures that I was showing. That shows you the 2 meters, the hazards during the event, and the changes present minus past. As input, what we have to give is simply the long latitude box for the event, the dates of the event, and 3 cities that are in a world cities database, and they are the cities where we want to study more in details the changes. So these are basically, but the code is not in the nature. Why? Because of this problem of the expert judgment. So if we prefer to have the control of the studies that come up, because if a too narrow region is selected to perform the climate meter analysis, then you can end up with changes that go in all the directions because you are not constraining the right way to the circulation. And we want to avoid that, like people who are not trained to properly use these methodologies can release studies that are not scientifically grounded in what we know from the meteorology.
Okay, thanks a lot. And so we will go to the last question, a more open question. So do you think thermal front parameter and frontal diagnostic parameter variabilities got also stronger recently, maybe as a root causes for extremes?
So what we see in the climate meter studies is that there is in all the studies the thermodynamic components, that is the fact that we have warmer conditions that drives not only heat waves or decrease in cold, but also the precipitation. So we know that for each degrees of warming we have 7% more rain. in the system, the weather system that we have. But in climate meter, we also see that, as I showed for the storm Ewing, that was my example, we have increase we have dynamical changes, so cyclones that are getting deeper, that produce changes in weather patterns, and sometimes more precipitation in some area and less in some other area. So yes, the thermodynamics component is getting stronger and is the main route for extremes, but climate meter also tell us that we don't have to forget that also the dynamics and so the meteorology of the event is changing, and this drive additional changes that can be the catastrophic ones for which you are not prepared.
Okay, well, thanks a lot for the explanation. So
Thank
we
you
are
very
reaching
much again
the
for
end
the
of the
invitation.
question.